Okay, the third case is we would like to find the confidence interval of the difference between the two means, population means, when, again, standard deviations of the populations are unknown. Not only this, they are not equal. So in the previous video, we discussed when they both are equal. We're still discussing two independent samples. So the confidence interval is going to be something like this. It's kind of a different formula than before. And we're going to adjust the degree of freedom, which is going to be something like this. Again, we will not be doing all of these manual calculations. We will be using Minitab to find all of this. Okay, the marketing staff at Texas State Bank in Dallas is planning to roll out a new marketing campaign addressed at increasing bank card use. As one part of the campaign, the bank will offer a low interest rate incentive to induce people to spend more money using its charge cards. However, the bank is concerned whether this plan will have a different impact on merit card holders than on unmerit card holders. So these are my two groups, two populations, merit card holders versus unmerit card holders. So prior to starting the marketing campaign statewide, the bank wishes to test the concept on a random sample of 30 unmerit and 25 merit. The managers wish to estimate the difference in mean credit card spending. So this is the goal, to estimate the difference in mean credit card spending for unmerit versus the merit customers for a 2-week period immediately after being exposed to the marketing campaign, right? Based on the past data analysts in the marketing department have reason to believe the spending distribution for unmerit and merit customers will be approximately normally distributed. Listen, the first assumption has been met in the question. Both populations, they have normally distributed curve, but they are unwilling to conclude that the population variances for spending are equal for the two populations. So the variances are not equal now. The variances are what? Not equal. If you remember, we have three assumptions. The first one, both populations have to be normal, which is okay. The second one, the variances of the populations, they are not equal now. So that's why we can use the other method, the new or the adjusted formula. The third one, the both samples, they have to be what? Independent. In this case, they are independent because we have unmerit versus merit, right? So what to do? Go to stat, basic statistics, to sample. We have summarized data, yes. So we are going to go to put the summarized data. The sample size for the unmerit, where is it? Unmerit, we have 30. We have 30 here. We have 25 here. Sample mean 455.1. Here we have 268.9, the spending, right? And now the standard deviation of the sample is this. First sample, second sample is this. We go to options. We have to build 95 confidence interval estimate, which is 95, that's fine. And what is the hypothesized difference? We assuming that mu1 minus mu1, there's no difference, 0, right? And the alternative hypothesis is the difference is not equal to the hypothesized difference. The difference is not 0, basically. There is a difference between the two populations, the unmarried and married. Maybe one is spending more than the other one, right? Assume equal variances? No. Take this off. Then okay, then we're done. Then what we got, basically, the confidence interval is 137.5. The 95% confidence level for the difference is what? It's 137.5 between $137.5 and $234.9. So the goal was to estimate the difference in mean credit card spending for unmarried versus the married. And this one doesn't contain the 0. Listen, this interval doesn't contain the 0. So what we can conclude, oh, maybe there is a difference. Maybe there is a difference in the mean. We're going to study this. But this one doesn't contain the 0, right? So there's an evidence that the unmarried customers, after being introduced to the marketing program, spend more than married customers on average, because we said the unmarried minus the married. The unmarried minus the married give us really, there is a difference. There is a difference between both of them. The unmarried customers spend on average more than the married customers, from $137.5 to $234.9 in the 2 weeks following the marketing campaign. This is the kind of the conclusion, because why do we conclude that the unmarried spends more than the married? Because this one doesn't contain the 0, so there's no way that the mu1 is going to be equal to mu2, right? The question is that because of the campaign? Is that because of the campaign is really effective? Or it's more effective for the unmarried compared to the married customers? Or no? Maybe we have to look at other factors, like their accounts, the customers' accounts before the marketing campaign. So these are something else. But in general, it's clear from the our analysis that our analysis says that the unmarried tend to spend more on average between this to this compared to the married people. So maybe we can write this somewhere here. There is evidence to conclude that unmarried customers, after being introduced to the marketing campaign, spends what? More than the married customers on average. Between what and what? Between 137 point whatever we got dollars and $234 in the 2 weeks following the marketing campaign. This is customers here. So this is the conclusion. There is a difference. The idea is there is a difference between the population means, because the 0 is not within the interval. This is important to understand. The 0 is not within that interval.